So without further delay, I'm going to hand over to George Ornbo, co-founder of Pebble, who's going to be speaking on what Node.js can do for the enterprise. Thank you.
Hi everyone, so yeah, I'm George. I'm shared on most social networks, so if you're really interested in Node, you can follow me and get spammed with loads of tweets about it. So in a former life, I worked at McKinsey and I used to be in wholesale banking there, but then left there and decided to do programming because it was really exciting and I was really excited by what was happening on the web. I'm a polyglot programmer, so I've kind of come through PHP, Ruby, bit of Erlang, then Node, and now increasingly interested in Golang as well. So I kind of have a good overview, I think, of what Node is and isn't good at from the perspective of other languages. And then up around about 2011, I started to experiment with Node and started to write some blog posts on it, and was approached by Pearson to write a book on Node. And in about 2013, I think it was published. So it's very much a beginner's introduction, but after that wrote some production applications. So I've been involved quite heavily with a gaming platform and wrote a chat service for that and some orchestration layer type stuff. I'm also the co-founder of Pebble Code, and my business partner Toby's here with me tonight. We're a business technology consultancy based in London. We work with AstraZeneca, Lloyds, Pearson and Al Jazeera, to name a few. We're using Node quite a bit with those organisations, and there is definitely a lot of interest in enterprise for what Node can offer. So just before we start, I want to touch on JavaScript, this amazing language. So there's not much code in this talk, but just to demonstrate the quirkiness of JavaScript, the top line is adding two arrays. So what might you expect to get when you add two arrays? Maybe an array. In JavaScript, you get empty string. The third line down is asking for the type of an array. So any sane person would say you get an array back. In JavaScript, you get an object. So there are some bugs in JavaScript that, because you can't really break the web, they're there in their language, and this is very distasteful to some developers and people from a more computer science type background. But the point is that JavaScript is unavoidable now, really. It's become the language of the web, it's present, it's becoming the platform of delivery for many applications, and I'll talk a bit about what browsers are doing and the APIs that are available now and why JavaScript is gaining such traction. So what is Node.js? I think there's this perception that it's JavaScript on the server, but actually it's not that. It was created in 2009 by Ryan Dahl, who was just a crazy creative person, and he decided to take Google's V8 engine from their Chrome web browser, which they'd open sourced, and try to create a programming platform with it. Now, V8 is a highly optimized C++ engine designed for browsers, but it so happens to be very good at networking and all the kinds of things that browsers do. So he took that and created a JavaScript API on top of that C++ engine, so the way you interact with it is through JavaScript. The reason he did that was because JavaScript maps very well to lots of the problems we're trying to do with distributed network programming. So particularly events, JavaScript is really strong at, and it maps really well to the problems we're facing on the web now. So it should be noted that Node is just one approach to concurrency, concurrency being one of the big problems in programming. So you might choose to solve concurrency by using threads, by spawning extra processes. Then you might run into locking issues, and I think anyone that's done any serious programming will realize that threads and managing state between threads can be really painful. So Node takes a different approach. It gives you a single thread to operate in, which means you have to program in a different way. It's asynchronous by design. So what that means is you kind of fire these things off, and you don't block your thread until they come back. And then when they come back, so say for example you're reading something from a database, when it comes back, you'll have an event raised which will call an anonymous function or a function of some kind, and then you can operate on it. So I'm not going to do these slides because unfortunately when I transferred from Keynote to PowerPoint, they got mangled. But yeah, the programming problems we're facing today are data is distributed more over networks. So historically we had an application tier that was maybe a database, an application tier, and a web tier. But now databases might be distributed over the web. We might talk to third-party APIs. We might have to report into third-party APIs. Applications are often part of a bigger service-orientated architecture. And I think the second talk is going to talk more about how microservices are becoming more important. But now when we don't have so much control over the applications we write or specifically the things we interact with. So this makes it more difficult to program. So the other thing we're seeing is a real shift in what server-side applications do. So historically, they've taken the view layer into the application, and you might build your view layer with templating on the server side. With the rise of client-side frameworks like Angular, Backbone, and Ember, and the capability of browsers, there's a trend to move more of the application logic into the browser. So then your server-side application becomes effectively an API. So it's more about the interface and the implementation. You could use any technology you want. You can swap it out quite easily. So say you want to shift from Node to Erlang. If the API is the same, it doesn't really matter. So it brings a lot of flexibility to your application if you abstract the technology away through a nice API layer. The other thing we're seeing is an increasing array of what clients are. Historically, it was browsers. But now you might be waiting for a bus and you can see the weather, or your fridge might be enabled with a network, your TV might be, and we have to, as application developers, present data to all of these clients, and some we haven't really imagined yet. So by taking the view layer out of your application and simply considering your application as data, it kind of future-proofs you really, because when somebody comes along and says, I want to put my app on a billboard, you can integrate it quite easily. So the other major thing to consider here is what's happening in browsers. So the web standards movement has done wonders, and people have worked really hard to get browser vendors to agree on API implementations. So now as developers, we have really rich access to things like hardware. So we can access, through the browser, we can access the microphone, the camera. On mobile devices, we can access things like vibration. And there's some really exciting possibilities opening up, specifically with WebRTC, which is a new technology where you can establish connections between browsers. So it's effectively peer-to-peer. So you can have video connections between people's browsers. And kind of 5 years ago, this would have just been cloud cuckoo land, but it's actually happening. So also you can get the location. An array of other APIs are available, and they're standardized now. They're quite reliable. Even Internet Explorer is really quite a decent browser now. The browser that's letting us down, surprisingly, is Mobile Safari, which is really lagging behind. The IE team are making great strides. They're embracing standards, but Apple are currently not really implementing all of the standards, I suspect for kind of commercial reasons, but they will implement them eventually. There's also some completely crazy stuff happening. So ASM.js is a project that allows you to cross-compile from C++ to JavaScript. So somebody took a gaming engine, the Unreal gaming engine, and cross-compiled it into JavaScript. So you could play a game, a full-on like real experience game in the browser. And in this instance, JavaScript is becoming effectively the assembly of the web. So you can cross-compile anything into JavaScript. It's quite a permissive language, so you can compile from maybe Ruby or C++, and there are already loads of these cross-compilers out there. So this is a really interesting innovation. JavaScript isn't being used to develop languages, it's being used to deliver it effectively as assembly. So my talk is a little bit more focused on Node, but I'm happy at the end to go more into the client-side stuff. But Node is cross-platform, out of the box, so obviously Chrome has an interest in being compatible on all platforms, and Node benefits from that. But also, Microsoft have got behind Node quite heavily. So it's a first-class citizen on Azure. They have a team that are contributing actively to the project. They're integrating it into all of their IDEs, and Microsoft as a business is using it quite heavily as well. So they're actively behind it, and obviously Linux and OS X have great support as well. And it's just as performant on Windows, really. The tests that have come out have shown really strong performance. So if you're a Windows team, it doesn't really matter if you want to deploy solely to Windows boxes. And also if you've got a polyglot team who like to work on different platforms, they can coexist. So GitHub as a metric for the most popular languages, you can probably see hopefully JavaScript at the top, which has been at the top for 2 years now. This isn't perhaps the best metric for enterprise adoption, but in terms of coding globally, this is the community for developers. So Java still is very popular, Ruby, C, and then it drops down to CSS and some of the other dynamic languages. NPM is the package manager for Node, and effectively you can think of it as Maven or Nant, I think it is. So these are all of the packages that have been created and downloaded on NPM, and really it's just been crazy growth. The number of contributions, the number of downloads, this particular chart shows 17 times growth in just over a year. So in terms of adoption in the wide community, it's really growing quickly, and NPM is a good reason for that. So if you've done any kind of client-side coding, it's likely that you've used NPM as well. So it focuses on small modules. So rather than building monolithic tools that you can use, often these things are maybe even 4 or 5 functions, which are very targeted. It's very easy to publish these and to share them, and there's a thriving community around this. They're mostly open source, and NPM itself can be considered enterprise ready. NPM actually spun out to be a separate business and has venture capital backing. So they've created a suite of products for the enterprise to have things like private modules and to host the registry in the cloud. So they're kind of thinking quite hard about real problems in the enterprise, and they've created products to do that with quite reasonable pricing. So yeah, the point about Node is that it's not a trash everything else technology. It can complement your existing stack quite well. So there's really good support in Node for most of the enterprise protocols. There's drivers for most of the enterprise database products. And what we're seeing is really that the usage is used to complement things like .NET and Java and to do things that Node's good at. So we don't see kind of in the enterprise businesses wholesale just putting all of their chips on Node, because frankly that would be stupid, especially with CPU-bound operations. So specifically, Node is not good at CPU-intensive operations. So if you're doing stuff that's going to lock up a process, just don't use Node. Use something else. If you're doing stuff where you're getting and receiving data really quickly, so a web server where you're reading a row from a database table and turning it into JSON and returning it as an API is a really good use case. So don't do data crunching, do really fast networky stuff, and Node will perform probably better than most of the technologies you've tried so far. So I've got a few case studies now about who's using Node and what they're using it for. So this is public information, which I've gathered from various talks, and the most interesting story is probably PayPal, but eBay are adopting Node quite heavily. Walmart have their entire mobile API layer written in Node. Node is very strong at HTTP, at managing connections, and specifically for mobile where the network is potentially quite unreliable. There's been some strong successes there. Netflix have just announced that they're migrating some of their core services to Node. Yahoo, I think, have built their mail product largely on top of Node. And Google are doing some strange stealth project where they're hiring most of the awesome people in the community, but we haven't really seen what that is yet. So use cases. I mentioned APIs. RESTful APIs are a really good use case for Node. There are mature frameworks within the community, so if you're interested, look at Happy.js, Express, or Restify. And there are some large-scale deployments and case studies. So I think tomorrow is Black Friday in the States, and last year Walmart live tweeted from their operations team how the APIs were standing up to the traffic. So there's some really interesting graphs about how their Node stack performed, and basically it was really boring, nothing happened. It held up really well, performance was great, CPU usage was low. Clearly they've got a large team that have dedicated hours and hours to making it work, but They were very open about their data and their stack. So if there's a really good case study there to show that it can work. Another reason for using Node for JSON APIs in particular is that Node is JavaScript. So working with JSON is really easy. It also integrates really well with other backends. So if you've got another service that you need to post data in or get data from, it can act as more of an orchestration layer. So this is the second really good use case for me, which is like a proxy layer over your other backend services. So maybe you want to convert an XML service into JSON for the browser. Node is a really good choice for that. Maybe you want to take a SOAP API and make it web-friendly. Node is a really good choice for that. So the latency that you'll see from Node is typically 50 to 150 milliseconds if you're on the same network and you're doing it well. So it's not a massive overhead, and the tools that are available within Node are quite straightforward. And in effect, it's not doing very much. It's just maybe transforming some data, maybe shimming an API that's a bit rubbish, maybe making data structures the way you want them. But it's a great tool for doing stuff with maybe systems that haven't been touched for 10 years and you don't want to open up that horrible black hole. You can just shim over the top and move forward quite quickly. So PayPal specifically, their adoption began in 2012 and they worked to replace some of their Java stack. And they basically picked a section of their Java stack and said, let's try and rewrite it in Node. So the way they did this was specifically to measure it, and I think this is a really valuable thing and something that anyone adopting Node should do. They looked at the lines of code, they looked at the number of people they needed to make it, and they looked at the performance. So what they found was that they got double the requests per second with the Java app, there was a decrease in response time, pages were served quicker, and the hardware that they needed to serve it was much lower. Now, this is obviously a very specific case, and you could argue that they knew exactly what they were building, so they had an advantage on the second team. But what I like about PayPal's approach is they measured everything. So when they were having debates about whether Java or Node was better for this specific problem, they were able to look at the data and make informed decisions. So if you are interested in how Node can change things culturally, there's lots of really good videos from Bill Scott available on the web. And he was really interested in kind of taking what was quite a slow process with Java. So designers and developers would have to go on, I think, a 3 or 4 week course to learn their Spring framework. And the view layer was hidden deep in the Java application. And he wanted the time to first commit and the first response from code to be quicker. And what he has spoken about was that has been made possible by adopting Node.js as a technology specifically for the front-end teams. And that necessitates that data is made available from APIs. But what the value to the business is that they can iterate much more quickly on their products. So they can experiment, and the time to get stuff out in front of customers and product owners is reduced. So I mentioned Walmart. I won't go over in detail what they did because it's available on the web and it's a really great case study. But yeah, really high traffic site, really high spikes in traffic. And the mobile API is specifically powered by Node and performed really well. So eBay, like quite a lot of these large organizations, they picked a small problem to experiment with, and their story is very much the orchestration layer. So they had a number of APIs that they wanted to pull together for customers, and they had an issue with strong cultural pushback from Java teams who didn't really rate a JavaScript-based server at all. So again, they used metrics and measurement to inform that debate, and they didn't put all of their chips on Node until they were certain that it was going to perform well. And since then, they've begun to build out more APIs and I think replace more of their Java stack, but that information is a bit less public, unfortunately. So to conclude, I think if you are interested in Node, it's relatively easy to pick a small problem and experiment with it. And you can build it, you can measure it, and you can learn. And if it's not better than your existing stack, maybe after a 2-week experiment, you move on. But a 2-week time period is not a huge investment. And if you think you could gain value from it, either from faster response times, faster time to market, lower server costs, there is definitely value in going further. So I think the use cases for me are small API services and the orchestration layer. Probably the advice I'd give now is to not put view layers in server-side code, to focus on building APIs, because then when the Internet of Things happens, you're not tied to rewriting your application. You can use it for any client. You use it on mobile, desktop, billboards, TVs, and anything that's got an Ethernet cord, basically. You also don't need to throw away your existing stack. So if you've got legacy APIs that you're not really interested in developing because the developers have left and it's too scary to kind of open that up, you can use Node to kind of modernize your API or move it forward. So I think one of the core drivers of Node's adoption is to speed up innovation. I think with startups becoming increasingly dangerous for large enterprises, they need to keep pace with innovation in the open market. And Node brings a culture that allows that, and that's explicitly what PayPal have done. And there are other organizations that have spoken publicly about the cultural thing they're doing. And specifically avoid making monoliths. So if your application's huge and a single-tiered application, it's very difficult to change. I think what the second talk potentially we'll look at is by breaking things down into discrete services, you can swap things in and out and modify your application more quickly. So you might think you know what your application needs to do now, but in 3 months' time, when the product's changed or your customers have changed, you're going to have to change it. And it's going to be quicker if they're small units of functionality than if it's a big monolith. Also, I'd like to say that technologies can coexist. I think we've kind of gone beyond the world where one technology can rule them all. Node, for me, has a specific use case. It's really good at networking. It's very performant. It's good at things that browsers are good at. And it's being used by large-scale enterprises. I would say if you're interested in engaging a bit more with Node, there's a really fantastic meetup every week in London, the London Node User Group, which is really friendly, and it has really good talks every month, quite often from people within larger organizations who are experimenting with it and using it. And it's still a relatively young technology. It's, 5 years old now. So yeah, people are very open about their experience of using it, because obviously other people are keen to hear that story. So yeah, that's it. I think I've got time for a few questions.
With JavaScript being the most popular language for the last 2 years, do you see a threat to that for next year, and if so, what language is that?
I don't think so on that chart, just because probably that chart is an indicator of client-side JavaScript and server-side JavaScript, and I'd say the grand proportion is probably client-side code, so there's lots of client-side JavaScript on GitHub. I think on the server side, concurrency is a kind of common problem now, which everyone's trying to solve. So specifically Golang would be in the same type of sphere as Node.js. Rust-Lang, which is Mozilla's newish language, is also a kind of new framework. But I think the attraction of Node is that it's relatively easy to find JavaScript developers. I think Golang developers and Rust-Lang developers are probably a bit fewer on the ground. So if you had to build a team for that, you'd probably find it harder than finding JavaScript developers. But I think all three of those languages have their merits, and it just kind of depends on your culture. And I also don't think that kind of enterprise languages are going to go away anytime soon.
When you look at something like Node, there's a lot of, because it's a dynamic language,
yeah.
On the back end you need a lot of sort of unit tests to go around it. Have you found that adds either to the development time, or it actually adds to the stability time to actually get products over at the end of the day?
Yeah, I think yes and no. So I think it definitely, like any language, it pays dividends to have a good test suite. One thing with Node is if there's an uncaught exception in your application, it will crash your process. So it's very much a fail fast and crash everything VM, which when you release something is a real nightmare. So like for the 10 days after you release stuff, you'll find bugs and you'll have to fix them immediately. But after that period, you get to stability very quickly because you're kind of forced to. But I think it's probably no different from any other language in terms of requiring tests, but there are other approaches, I guess. So something like TypeScript, which brings strong typing to JavaScript, which is a kind of cross-compiler. So if you're really interested in defining your types and having a bit more type safety, there are some options there if you want to go that route. And lots of shops do that.
Do you think that's more applicable in the enterprise world than the startup world?
I think say for example, your team were transitioning or doing .NET and doing Node as well. I think there might be some value in looking at TypeScript and as a team deciding if it's something you want to do. I think TypeScript was designed by the same guy that designed .NET. But also similarly, if you're working with a load of vanilla JavaScript developers, they'd have to learn another interface into the language they already know. So I think it's kind of being pragmatic about that for whatever's more productive for the team.
You mentioned a couple of Node frameworks like Express and Node.js.
Yeah.
Do you have any favorites or their preferred use cases for one over the other?
Yeah, so I think Express is fantastic for prototyping UIs. So it gives you a templating layer if you want to put your templates server-side. It's also pretty good at doing APIs. Happy is a very fully featured API library. So it's the library that powers Walmart. So all of the problems that Walmart have been kind of solved. So like caching, authentication. It's got loads of features, but for a small project, it's probably got too many. There's another one, Restify, which is quite good. It just depends on the scale of your API. I think for smaller projects and getting into Node, Express is a really accessible way to do that. But then you'll find that Happy.js has probably solved all of the problems that you're likely to have.
Presumably Restify, if I'm just running Restify.
Yeah, Restify. They're mainly designed for REST APIs, those three frameworks. So there are a couple of RPC-style API libraries, but those three libraries are specifically REST API libraries. Yeah.
Sorry, what are your thoughts on the impact of ECMAScript 6 on the way Node.js functions, in terms of generators and Code.js and libraries like that?
Yeah, well, I think it's fantastic. It's kind of great that the language is moving forward, and on the client side as well, I think we can expect to see ECMAScript landing relatively soon, but just having that let syntax and kind of having written JavaScript in anger, it's not the nicest language to work with, and it's got some quirks and it's got some flaws, and I think they haven't all been addressed. And there are still some horrible bugs in JavaScript that, because they will break the web, are going to be there for a while. But I think ECMAScript is a great step forward. ECMAScript 6 is a great step forward. And actually in Node, if you use the Harmony flag, I think it is, you can use those features today. So actually programming on the server, you get access to the spec way before the browser vendors have implemented it.
Have you seen an increase in the use of JavaScript functionally, especially in data transformation? I know you were mentioning API gateways.
Yeah, a little bit. So I have seen, in terms of kind of pipelines for pushing stuff maybe through other tools, so things like Hadoop or Redshift, it might be that Node does maybe some data transfer before it goes into that pipeline. But for kind of heavy algorithmic data transforms, I probably wouldn't really recommend JavaScript because it's not the nicest framework to work with for doing that. But I know there are some people doing it, and if you're crazy enough to want to do it, it's doable. But I think there are probably better languages to do it in.
I've got two questions. The first one would be regarding to test-driven development. What sort of frameworks and components have you found is a good workflow to do test first instead of basically just patching it on together?
Yeah, sure. So Node ships with an assert module, which is your kind of standard comparing truthiness and falsiness. But also there are a lot of very good test frameworks. So the one I'd probably recommend is Mocha.
Yeah.
I've used that to build a full test suite for unit tests, functional tests, integration tests, and Node integrates really well with CI servers. So if you want to do continuous integration, You could use something like Grunt to run those tests. So you can have a kind of full professional workflow, and the tooling around it is pretty good.
Yeah. Second question, if I may. Yeah, we're looking into different things to also make our API routes that are accessible via the Express server also accessible via the socket IO layer, because many times you have the use case where you want to access things as an API route for like a one-time request, but requests are very slow, and if you want to transfer real-time data and make it all broadcast and use like Redis or certain things on the server side to broadcast to many clients on the multi-process architecture. It's nice to be able to have a socket connection and then also request the same things. But you don't want to kind of duplicate your API routes with then also writing the same wrappers to forward to the same functions that all your socket functions are pointing. So is there anything integrated in Express or maybe Happy or any of these ways where you can kind of get access to these things via socket IO but also as an API route?
Yeah, I haven't heard of anything specific, but I mean, you could do something like abstract the calls for the data into another layer and then reuse that method. But,
that's what we're doing currently, but it seems like, we're basically rewriting this part of the layer in the middle where basically the thing that defines your API route